Okay, we start with pre-UPS set A, section A, reaction rekinetic. So there are 5 questions in this section. Answer all questions. Which of the following statement is correct about effective collision? There are 2 factors that affect effective collision. So we know it's about EA and also the orientation. Okay, so look at the answer. Colliding molecule must possess minimum energy equal to or less than. So this is incorrect statement because the kinetic energy must equal to is equal or greater than EA. Okay, the first statement is incorrect. Colliding molecule must possess energy equal or greater than activation energy. So this statement is correct. And collide at correct orientation. Yes, this the second one also correct. So the answer is B. Okay, but we look at the third option here. The colliding molecule must possess energy equal to or greater than activation energy and collide. Okay, this statement is incorrect. Colliding molecule must possess energy equal to or less than. Okay, less than. The statement is incorrect. Okay, we go to the second one. Uranium-238 will decay half from its initial concentration in 4.5 billion years. This statement is an example of application of the concept. Of course, the answer is half-life because half, it decay half. So the answer is D. Which of the following statement about catalyst is true? So we know catalyst is a substance that increase the rate of reaction. Without itself being consumed. And catalysts provide an alternative pathway which has a lower activation energy compared to the one without catalyst. So look at the answer. Catalysts change the mechanism of reaction. No. Catalysts increase the amount of product. No. Catalysts decrease the enthalpy of reaction. Also no. It's not will effect. The catalyst does not take part chemically during the reaction. Yes, this is the correct answer. As I said before, the catalyst increase the rate of reaction without itself being consumed. So the answer is D. Okay, we go to the next one. For the reaction 2NO react with 2 mole of hydrogen to produce 1 mole of nitrogen and 2 mole of water. The rate law is given. Rate equal to K, concentration of NO power of 2 times the concentration of hydrogen. Which statement is incorrect? Careful with this one. Incorrect to represent the reaction. So look at the answer. The reaction is second order with respect to NO. Yes, this is true. Second order. Okay, the reaction is first order with respect to H2. Yes, this is also true because this is power of 1. The reaction is second order with respect to H2. So this is incorrect. The reaction is third order. So 2 plus 1 equal to 3. So overall is third order. So the final, the incorrect statement is the reaction is second order with respect to hydrogen. Okay, next question. Based on Arrhenius equation, it can be said that, okay, so we know the Arrhenius equation K equal to AE exponent negative EA over RT, or ln K equal to ln A minus EA over RT. So according to this statement, we know that the rate constant K is directly proportional to the temperature. is directly proportional to the temperature. And also we know that K is inversely proportional to the activation energy. This one. Okay, so look at the option here. The temperature decrease, the rate constant increase. The temperature increase, the rate constant decrease. So this statement is incorrect. The activation energy increase, the rate constant is increase. Okay, look at the answer here. Okay, the activation energy, yes, this one, this one, increase, the rate constant increase. This is also incorrect. The activation energy increase, the rate constant increase. So salah lah. This is incorrect. So the activation energy decrease, the activation decrease, the rate constant decrease. Okay, because rate constant and EA is inversely proportional. The temperature increase, the rate constant increase. So this statement is correct. The temperature increase, the rate constant increase. So the answer is D. Okay, B and C is directly proportional between activation energy and rate constant. Actually, the rate constant is inversely proportional to the activation energy. Okay, we continue with section B, thermochemistry. There are also 5 questions in this section. Okay, we still in pre-UPS 1. The specific heat capacity, specific heat capacity of aluminium is 0.9 joule per gram per degree Celsius. Which of the following correctly explain the above statement? Okay, so we have unit joule per gram per degree Celsius. Okay, look at the first answer. The first option here. 0.9 joule energy is needed to reduce. Okay, the keyword reduce is incorrect. Actually, it must increase, not reduce. So the first statement is incorrect. The second statement also incorrect because it used term reduce. So look at the C, option 3 and option 4. 0.9 joule energy is needed to increase the temperature of 1 gram of aluminium by 1 degree Celsius. Okay, this statement is correct. This statement is correct because it shows that 0.9 joule energy increased by 1 gram and 1 degree Celsius. Okay, so this is the answer. Okay, look at the option D. Why is incorrect? 0.9 energy is needed to increase the temperature 1 gram. But it not mentioned about temperature. No temperature here. So this is incorrect. So we go to the next question. Which of the following enthalpy change is associated with the following equation? So according to the equation, we know that this is an element, carbon, react with an element, hydrogen, to produce CH4. So this is enthalpy formation. Enthalpy formation, the heat change when 1 mole of substance is formed from its element. So enthalpy formation. Okay, next we have the following energy profile diagram representing, okay, so we have A, B, C and D. Okay, this is endothermic because the inertia is lower, the reactant, the energy of reactant is lower than the energy of product. So this is endothermic. The statement A and B is incorrect. Okay, endothermic reaction with enthalpy of reaction C. Endothermic reaction with enthalpy. Enthalpy is the change between reactant and product. Okay, so this is C. So this is correct. Endothermic reaction with enthalpy of reaction B. B is activation energy. So the correct statement is C. Okay, next, ionic solid with high lattice energy consists of, okay, we can relate two factors here, which is the size and also the charge. Okay, so according to this answer, atom with bigger size and smaller number of valence electron does not have higher lattice energy. Bigger size make the attraction of lattice energy will become smaller. So this is incorrect. Ion with bigger size, okay, the lattice energy actually it will become high when the size is smaller and the charge will be increased. So we find the answer, ion with bigger size. Okay, this is also incorrect. Ion with smaller size, yes. Higher charge, yes. So the answer is C. Sorry, the answer is C. Atom with smaller size, greater number of valence electron. Okay, this statement is incorrect because it used the term atom. Actually, the lattice energy is the attraction between ion, positive and negative. Okay. Next, lattice energy of lithium chloride is greater than sodium chloride. So we look at the ion lithium and sodium. Which of the following is correct to justify the above statement? So lithium and sodium, it located at period, this one 2, sodium 3, group 1. This is also 1. So group is not our character to discuss. We will discuss in terms of period. So in terms of period, the size of lithium is smaller than sodium. So the previous question we have discussed, the high lattice energy occur when the size lower and the charge higher. So in terms of size, the size of lithium is lower than sodium. So lithium ion is a smaller than the sodium. Okay, lithium ion is smaller than sodium ion. The charge, okay, this is incorrect because it both have same charge. The ionic radii of lithium ion smaller than sodium ion. This is the correct statement. Okay, I think that's all. Okay, we're still in pre-UPS 1. Now we continue with section C, electrochemistry. There are 7 questions. So look at the first question. A cell notation of galvanic cell is given as it is. Which of the following is correct regarding to the cell? So according to the cell notation, we know that it uses She as an anode and zinc as cathode. Anode. Okay, so the correct statement regarding to the cell, the hydrogen half cell at as cathode. So this is incorrect because She at anode. The zinc half cell at as anode. This is also incorrect. The zinc at as cathode. Zinc is the reducing agent. Zinc is the reducing agent. So reducing agent means it occur oxidation. Oxidation at anode. So this statement is incorrect because zinc occur at cathode according to the half cell. So hydrogen is the reducing agent. So same. So occur oxidation at anode. So the answer is D. Hydrogen is the reducing agent. Okay, next question. Which of the following equation is correctly representing as electrode potential? Or we can state here standard electrode potential, electrode reduction. Reduction electrode potential. So for reduction, it must receive the electron. So option 1 and 2 is incorrect. We go to option 3 and 4 because reduction receive electron. Reduction receive electron. Okay. Look at the oxidation number. This is positive 1. It will become positive 2. So increase number of oxidation number. So this is incorrect because reduction must decrease the oxidation number. This one is positive 2 to become positive 1. So it reduce. So the answer is D. Okay, we go to the option number 3. What is the product form at anode when a concentrated solution of sodium chloride electrolyzed using inert electrode? Okay, so the keyword is concentrated solution. Okay, at anode. So at anode, we have here sodium chloride. Sodium chloride. So Na plus and Cl minus. Cl minus will go to the cathode. Cl minus will go to the anode because it an ion. So since it's concentrated, the answer is chlorine gas. Chlorine gas. Okay, next. What is the product form at cathode? Okay, this one for cathode. 1 molar aqueous copper sulfate solution electrolyzed using copper electrode. So at cathode now we have copper 2 plus, copper electrode solid, and water. So in this case, copper solid will not choose because copper solid cannot reduce. It only occur oxidize. Okay, so between H2O, this one is inert reduction is 0.34, 0.83. This is 0.34. So according to proc, because it occur at cathode, so it must be more positive. So the answer is 0.34. So copper 2 plus, it will receive 2 electrons to produce copper solid. So the copper solid will deposited at cathode. Okay, amount of product formed at both anode and cathode during electrolysis can be presented by using Faraday's first law. Okay. Next, we have when will the equation be put to use? E cell equal to E naught cell minus RT over NF log Q. This is Nernst equation. So when the concentration solution is not 1 molar, okay, acceptable. When She is used as the cathode, no, we can use with other half cell. When the temperature is 25 degrees Celsius, no, this is at STP. When the pressure is 1 atm, this is also at standard temperature and pressure. So the best option is the concentration is not 1 molar. Okay, consider the following half cell equation. Choose the strongest reducing agent. So according to this one, this is reduction. Reduction from right to left. From left to right. So oxidation occur from right to left. Okay, so strongest reducing agent, which is Nora. So reducing agent, it must more negative. More negative is here is more negative. So the species that occur oxidized is P minus. So the answer is P minus. Kita baca terbalik lah. Sebab oxidation from right to left. This is oxidation. Oxidation. Reduction from here. From left to right. Okay. So the answer is P minus. Okay. That's all.